Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in the last video we talked about this, okay? I will give an example with this. Please watch the last video, it will help a lot. We did all this in the last video, okay? So in this video we just hit on what we mean by this, and this. Now, since we've established the concept, the basic concept of Maxwell's equation, saying that there are four equations that tells us how electric and magnetic field behave and how they interact. Since this is about electric and magnetic field, okay, we can give the four equations. We might say there are four equations, right? That explains their behavior. So these four equations can come in the form of general sets, okay? General sets. I should highlight that. They can come in the form of general sets. They can come in the form of static fields, okay? Static fields, let's highlight that. Static fields, and then time-harmonic versions. Time-harmonic versions. Now these are the three things you need to bear in mind. All the rest, all these many statements, point and integral, you can see it here. We have point and integral here. We have point and integral here. We have point and integral here. Okay? The only difference between A, B, and C is general set, static field, harmonic versions. Time harmonic version. So the thing is this. These four equations of Maxwell, we can write them in general form. What does this general form mean? That means equation 1, equation 2, equation 3, equation 4 of Maxwell's equation. We can write these four equations in general sets or in general form. And when we write them in general form, we write them in point and then in integral. When we say general form, we mean we are considering the source. Back to this example, we are considering the source, that's what causes the field. We are considering the source and we are considering the field in motion. That's the movement of the field, okay? How the field is propagated, okay? So that's the general form. But for the static form, we do not consider how the field, moves. Okay, we do not consider that. We consider the source, what causes the movement. Please watch the last video to understand this example here. Okay, then for the third one, time harmonic inversion, we do not consider the source, we consider the movement of the field. I hope we get the difference. So for the first one, we can say both source and field movement, okay, movement. Then for this one, just the source, okay, just the source. Then for this guy, just the movement. Okay, when we say movement, like the change with time, how time affects that, just the movement. This idea of just the source, just the movement is an informal explanation, okay? Just an informal explanation so that you get the main gist, you get the main concept of this thing, okay? So that means we'll have these four equations written. This first set will have four equations. Second set, the same four equations, but focus on the static field. Third set, four equations again, but focus on the time varying field, okay? Time harmonic. Okay, when we go into them, you understand what we fully mean. So this is just the first one, which is the A part we are going to deal with, okay? But we'll deal with that in the next video. Then when we say point and integral, meaning for each of the equation, I know this appears like much. So for the general set is divided into two again, okay? General set is divided into point and then integral. Static field, you're not divided into point and integral. harmonic and time harmonic point and integral, meaning the 4 equations will write them in point form, write them in integral form. Okay, don't worry, it's all good. So the next video will start with the first one, which is the point and integral form for general sets. Okay, so this is just the how it looks like, and then we'll go into this in the next video. So of course, comment, like, share, subscribe, and I'll see you in the next video. Thanks for watching, and bye for now.